Today I am going to start some important topic of the NEET and JEE like Newton's law of cooling, calorimetry, heat engine. We will solve the mathematical derivation plus problem also. These are the important topics for the NEET and JEE. From this section of NEET and JEE they will ask. Correct? From the heat chapter. In the heat chapter everything is not important. Like thermodynamics is the important topic and calorimetry is the important topic. Newton's law of cooling is the important topic. 3 to 4 topic is the important topic in the heat and thermodynamics where the 80 to 90% question asked. Like heat and thermodynamics is the big, okay, but they don't ask everything from each and every section of the part. Okay, some like some specific area they ask either NEET or JEE. So today I am going to do with first topic like in the heat, and today I am going to finish all the heat, okay, with the problem also. Like today I am going to do the kinetic theory of the gas, heat engine, Newton's law of cooling and calorimetry. Correct? First, kinetic theory of the gas. What is the, you know that what is the kinetic theory of the gas? Like gas particles move. Suppose any system is there, gas particle move one position to another position. Then you have to apply the kinetic theory of the gas. Already you have studied in the mechanics. What is the kinetic energy? Half mv square. Same like physics, everywhere is the same. There is no difference. Okay? There is no difference. Everywhere same concept apply, but structures change. Concept is remains same in every area of the physics. Every area on the physics working one principle, that is called the energy conservation. Okay, but in energy conservation there are so many variation. Like you will study mechanics, you will study heat, you will study the sound waves, you will, one second. Okay. Sorry. Voice and coming. Check voice. Online, all you are connected. Online, all you are connected. Are you able to listen my voice? Okay, okay, okay. No, other online student they are connected. Okay, we will move on. So, like kinetic theory of the gas, what we study in that one postulates and assumption. Okay. So, what is the postulates? Like molecular composition. See, all of you see here, molecular composition. Gas consists of large number of identical teeny molecules of atom in a continuous random motion. This is the molecular. Suppose you take a gas in a system. Suppose this is a system. In this system you take a gas. So all molecules will be the identical. Okay, all molecules will be the identical, and there inside the system continuous random motion. Okay, so this is the molecular assumption. First, negligible volume, the actual volume occupied by the gas. Volume is neglected. When you take the volume of the molecules, atoms, their volume, going to be the neglected. Okay, suppose container volume is the, when we are going to take the container volume in comparison to the gas molecule volume, will we are going to take a neglected. This is the second postulate. Okay, this is the first. Now third, intermolecular forces. Okay, there are no attractive or repulsion forces between the gas molecule. So third one, what is the intermolecular forces? There is no attractive force or repulsive forces inside the container, okay, between the gas molecule. Okay, next, elastic collision. Collision between the molecules, and between the molecules container walls are perfectly elastic. So suppose you take molecules inside the gas, okay, you have to apply the kinetic theory of the gases. So what in there, elastic collision will be happen, means elastic collision will be happen means momentum conserve and kinetic energy conserve, and all molecules moving in the random and one dimension. Okay, so there is also random motion and short collision duration. Suppose two molecules collide, there is a duration of the collision of the molecules will be the short. Okay, so this is the postulate and assumption of the kinetic theory of the gases. Okay, got it? Understand? See, what I discussed, kinetic theory of the gas. First topic I have discussed the kinetic theory of the gas. What I told in my session, whatever I will teach, you have to be the expert, not simple. Okay, so first I have given you the concept regarding the kinetic theory of the gases. So everything you know about the kinetic theory of, now how it will work. See, just go for the simulation, kinetic theory of the gas. When you will understand the simulation, then you will understand the 100% of the concept. When you understand the 100% of the concept, then you are able to solve the problem. See, temperature I just decrease, correct? Number of molecules increases. Number of molecules increases, temperature decreases. Volume of the container also decreases. Okay, now you see the, apply the kinetic theory of the gas concept. See there, when temperature increase, how this, correct, you are going to increase the temperature like 360. Okay, I have just draw the graph between the molecular speed and the probability density. When it is graph is possible when you apply for the kinetic theory of the gases. Just I increase the temperature, number of molecules also increase. See, container volume also increase. Now you will see how there. Okay, see there. Now decrease. When you are going to decrease the temperature, see there. Correct? Any doubt? See there. See, there is a how much effect of the temperature in the system. Okay. Suppose you decrease. See, linear. You slowly increase the temperature. Okay. Next. Now, decrease the number of molecules. I have decreased the number of molecules. Now increase the temperature. Correct? Now container volume I am just going to increase. Now you see the doubt? No. Understand? Next concept. Pressure derivation in the kinetic theory. Okay? What we have to study? Pressure derivation in the kinetic theory. Suppose you take an ideal gas. What it means by the ideal gas? Those who follow the PV is equal to nRT. That is called ideal gas. In the ideal gas, actually this is the okay. So in an ideal gas, just I have started before 5 minutes back kinetic theory of the. Just I have started this one kinetic theory of the gases. In that kinetic theory of the gas, just I have explained about the concept like molecular composition, negligible volume, no intermolecular forces, like elastic collision, random motion, short collision duration, Newton's law apply. Just I have started. This is the theoretical section. All you, those who joined just now, go through this one. This is the theoretical. Okay. So you can take the notes or I will send you or take the screenshots. That is easy. But kinetic theory of the gases, I have just go through the live. You see there. See. Kinetic theory of the gases depend on temperature, volume and number of molecule. Okay. So when you decrease the temperature, see how it is behaving. So slowly you increase the temperature. Okay. Now slowly you increase the number of molecules. Now decrease the volume, container volume. Okay. Now you see the what is the effect happen. See, slowly increase temperature. Number of molecules I put remains constant. Container volume remains constant. What I do, I am going to increase or decrease the temperature. Okay. So this is the practical or this is the live part of the kinetic theory of the gases. But main thing is that this is the theoretical section of the kinetic theory of the gases. Okay. So those who joined just now, just you note down 5 minutes, then I will come to the next. Are you able to listen my voice, Sanupriya?
Yes, sir. Clear, sir.
Okay.
Yes, sir.
Okay, nice. Then you note down everything. Then I will come to the all of you next topic. Today chemistry session. What time? 7. When you complete, all of you, let me know.
Sir, completed.
Okay. Next. Now come to the pressure derivation of the kinetic theory of the gas. Okay. See, just we are going to do the pressure derivation. Okay. What is the pressure? Like suppose consider an ideal gas in a container. Like I container have a length L, N is the number of molecule of each mass small n. Correct? So molecule collision Vxi, Vyj, Vzk. Okay. After that we'll get this one. What is this? Just this is the Vxi plus Vyj plus Vzk. This is the molecules in a container move in the x-axis, y-axis and z-axis. Vxi means velocity along the x-axis, Vy means velocity along the y-axis, Vz means velocity along the z-axis. This is the velocity in along all the three direction. Okay, so this is there, and after that this one. After, okay, so next, when like kinetic theory happens, okay, then it means velocity happens means momentum also change. Okay, what is the change of momentum? Change of momentum means nothing but initial momentum minus or final or minus initial. Okay, so momentum change, this is the momentum change. How much you are getting? Minus 2 mvx. You don't get confused what this one. This one means v of x. This is not minus. V of minus x means v of x. Don't get confused. Like here, force on the wall, F minus x. This is the Fx. Correct? Fx. Okay? So don't get confused. Okay? So force on the wall, mv square x square by L. mv x square by L. This is the force on the wall. Average velocity relation 1 by 3 v square. This is the average velocity relation. So final result is there 1 by 3 nm v rms square. This is the what? Final result of the pressure derivation in the kinetic theory of the gas. Okay. So when you are going to the school exam or board exam, then maybe they ask the derivation section, but in the IIT or NEET, correct? IIT mains or advanced or NEET, like in this directly you have to use this concept. Okay, but don't think that directly we will read this concept. You have to know each and every concept inside the physics, either derivation part, either mathematical, either life. Okay, so this is in pressure. Again I am going to explain you what is the pressure derivation in the kinetic theory. First we will consider ideal gas in a container. Second, molecular collision. Third, momentum change. Fourth, force on wall. Then we will find the total force. Sixth, average velocity relation. Then finally we will get the this value. Okay. So means like for the again I am going to explain you for the derivation part. You have to consider the sixth step. First, an ideal gas in a container. Second, molecular collision. Third, momentum change. Fourth, force on wall. Fifth, total force. And I am asking all of you again and again, don't get confused what this one. This is not minus. This is means this one. Correct? Like V of minus this one. It means not like that. This is the V of X. Okay? Or you will see V of minus Y, but not like this is the V of Y. Okay? So don't get confused the writing part. Okay? Try to understand the 100% concept as well as the derivation as well as the real physics. Okay? So this is the pressure derivation in the kinetic theory of the gases. Understand? So note down.
Completed, sir.
Okay. Next. See, I have seen the Now come to the kinetic energy and temperature relationship. We know kinetic energy is nothing but half mva square, correct? But there is also relationship with the temperature. Now you can ask what is the, why we will use the temperature relationship, correct? Why, what is the use? Because see, like when you go to the kitchen, okay, start boiling the water. Initially slow temperature, when temperature will rise, you will see the molecules will collision more and more. So in that collision you will see the boiling, fast fast boiling will be started. When the boiling fast is started, it means inside the molecules are going to collide so fast, means kinetic energy increases so fast and fast. There is a more random motion started. When more random motion started means it will depend on the temperature. How it will depend on the temperature? More random motion started, more motion started, more velocity started. Means also you will see starting boiling more. Okay, so we can say that there is a relationship between the kinetic energy and temperature. Doubt? No. So kinetic energy temperature equation 1 by 3 V RMS is equal to K into T. What is the M? M is the molecular mass, V RMS is the root mean square speed, K is the Boltzmann constant, and T is the absolute temperature. So this is the relationship between the kinetic energy and temperature. 1 by 3 V RMS is equal to K into T. Okay. Here you will see the degree of freedom. Like monatomic gas, there are three types. First, monatomic gas, degree of freedom is F is equal to 3, translational. Diatomic gas, F is equal to 5. F is equal to 5 means 3 translational, 2 rotational, correct? Now comes to the equipartition of the energy. One second. So these two concepts you understand. First, kinetic energy temperature equation. Okay. In the kinetic energy temperature equation, equal nothing but 1 by 3 V RMS is equal to K into T. Second, degree of freedom. Third, equipartition of energy. Okay. U is equal to NF by 2 RT. Okay. So this three derivation you have to know. Means three equation, no derivation, three equation, and these three equation depend on the relationship between the kinetic energy and temperature. Okay, and I have also explained you how the kinetic energy depend on the rise or decrease in temperature. Now simply in your house, like electric stove or gas, just slowly you increase the gas or decrease, automatically you will see the boiling will affected. When you increase the gas volume, gas level, boiling suddenly, there is a kinetic energy and temperature relationship there. So it is such type of things happen. Okay, note down that. Come to the next concept. Calorimetry. Then calorimetry. Okay. So heat transfer and phase change. One day I also explain what is the calorimetry. Okay. So today again I am to do to the calorimetry concept. So what is the first you try to understand what is the calorimetry. So calorimetry is the scientific study of heat transfer and measurement of heat change, where the heat transfer is going or where the phase change is going, then we will use the calorimetry during the physical and chemical process. When we will use the calorimetry? During the physical or chemical process when there is a phase change or heat transfer. Understand? When there is a phase change, what is means by phase change? Solid converted to liquid, liquid converted to vapor. This is the phase change. And heat transfer, suppose heat is going transferred from system to surrounding, surrounding to system to surrounding or surrounding to system, we can say that the heat transfer. So what is the use of calorimetry? Usage of calorimetry is to measure the heat transfer and phase change. Either you do the physical or chemical process. Doubt? In that one, you will see a specific heat capacity, S or C. So what is the specific heat? Amount of heat required to raise the temperature of 1 kg of substance by 1 degree Celsius or 1 Kelvin. What is the specific heat? So suppose this is a substance 1 kg. This is the 1 kg. You have to raise the temperature by 1 degree Celsius or 1 Kelvin. Then we can say that the specific heat. Correct? What is the formula? Ms delta T. What is the M? Mass. Delta T is the change of temperature. S is the specific heat. Okay? Now come to the latent heat. Already I discussed what is the latent heat. Latent heat, heat observed or released during the phase change at constant temperature. Suppose you are going to convert this liquid to solid, or solid to liquid, correct? During conversion of solid to liquid or liquid to solid, it means you are going to convert phase change. My concern is there, this water you are going to convert into ice, ice converted into water, going to convert into water. In this process you are going to, what you are going to do? Phase change. So phase change is there. We can say that how much heat observed during the phase change, how much heat is going to be observed. Okay. So we can say that the latent heat. What is the latent heat? During the phase change, how much heat observed or released? We can say that the latent heat. So there are two types of latent heat. First one is the latent heat of fusion. Second one is the latent heat of vaporization. Okay. So latent heat of fusion. Solid. What is the fusion? It means you take a ice converted to liquid. We can say that the latent heat of fusion. Ice to liquid. Fusion. Okay. And vaporization, liquid to gas. We can say that the vaporization. Okay. Doubt? So latent heat concept formula, Q is equal to M into L. M is the mass, L is the latent heat. Now come to the principle of calorimetry. Now I am going to come what is real the principle of calorimetry. How, see, what is the principle of calorimetry? For an isolated system, the total heat lost by the hotter body equal the total heat gained by the cooler body. So this is the principle of calorimetry. Suppose you take a cup of coffee, okay? Heat is transferred from the cup of coffee to your body. So you are feeling hot. Then what principle of calorimetry will work. When the principle of calorimetry work, total heat lost is equal to total heat gained. In that situation, principle of calorimetry will work. Understand? So this is the real concept of the principle of calorimetry. Total Q lost is equal to total Q gained. Okay? Now see the graph. Heating curve of water. Just I have draw. See, boiling water, liquid, melting Q, ice, solid. Okay. When you increase the temperature, you will see the everything. Just you note down full concept.
Completed, sir.
Just I am going to the next concept. Newton's law of cooling. Okay, wait. This is your question. Tomorrow you will get. Okay, total 45 questions are there. You will get the printout there. Now, Newton's law of cooling. Just see the what is the Newton's law of cooling in the book. Everything written, but main thing we don't understand the book. Correct? So actually, what is the Newton's law of cooling? How it will work? What is the application of the Newton's law? These all things we have to know. So Newton's law of cooling, the rate of heat loss of a body is directly proportional to temperature difference between the body and surrounding. Suppose I am feeling cold. Okay, I am feeling cold. So the rate of heat loss of a body is directly proportional to temperature difference between my body and surrounding. Suppose this is the hot, so this is the hot inside the hot water, inside the hot water. Now what is slowly it is going to be cool. So what is the Newton's law of cooling? What is the concept here? Newton's law of cooling, the rate of heat loss of a body is directly proportional to temperature difference between system and surrounding. This is the Newton's law of cooling. Understand? See, proportional relation dt by dt. One is the capital T is the temperature and small t is the time, is directly proportional to minus T minus Ts. Okay, one is the temperature of the system and one is the temperature of the surrounding. Okay, next, introducing constant of proportionality. So dt by dt is equal to minus k into T minus Ts. Okay, so after you remove the proportional sign, then you will put a constant. Okay, so dt by T minus Ts is equal to minus k dt. So separating variable and do the integral. correct? After integral you will get this one. So applying the all the initial condition, dt by dt minus k t minus ts, separating variable dt by t minus ts is equal to minus k dt, integrating dt by t minus ts is equal to minus k dt. Okay, ln t minus ts is equal to minus kt plus c. So applying all the initial condition you will get c is equal to ln t minus ts. So final exponential decay formula tt ts plus t minus ts e minus